Hello everyone. Now you will learn how to construct a shift register using RSDJK flip-flop and verify the result. This video is split into two parts. Part 1 will contain how to construct a shift register and verify it in part 2. At the end of this video, you will be able to construct a shift register using the RSDJK flip-flop and verify their results. Let us collect all the tools, equipment and materials required to do this practical. A digital trainer kit with user manual IC74LS279 with datasheet, IC74LS379 with datasheet, IC74LS04 with datasheet, IC74LS76 with datasheet, 2 numbers. Male-to-male jumper wires as required. Magnifying lens. Constructions of parallel shift register using RS flip-flop IC74LS279. The 74LS279 is a quad SR flip-flop latch IC with 16 pins in a dual in-line package. Since the IC74LS279 did not have the clock input provision, the construction of the circuit is used to transfer the given input data to the parallel output. This shift register circuit requires two ICs. They are IC74LS279 and IC74LS04. Identify the code number printed on both ICs, IC74LS279 and IC74LS04 using magnifying lens. Identify the pin number 1. It may have a small notch or dot to indicate pin number 1. Make sure that the IC is correctly aligned in the right position over the breadboard in the digital trainer kit. Gently insert both lines of pins of the IC into the breadboard, ensuring that each pin goes into a separate hole. Be careful not to bend the pins or force them into the holes. Connect the pin number 8 to ground and pin number 16 to power supply plus 5 volt VCC of IC74LS279 and connect pin 7 to ground and pin 14 to VCC of IC74LS04. Connect pins 1, 5, 10 and 14 of IC74LS04 to toggle switches as A, B, C and D respectively. Connect pin 1 of IC74LS279 to pin 1 of ICLS7404. Connect pin 2 of IC74LS04 to pin 2 of IC74LS279. Likewise, connect NOT gate between R and S input for the other SR flip-flop latches as shown in the circuit diagram. Switch on the plus 5 volt power supply VCC. Apply the desired parallel input data to the data input lines A, B, C and D based on the bit width of the shift register. Check the parallel output lines Q0 to Q3 to see if they reflect the loaded data. The output should match the applied parallel input data. Parallel input 1, 0, 0, 1. Parallel output 1, 0, 0, 1. Parallel input 1, 0, 1, 1. Parallel output 1, 0, 1, 1. Parallel input 1, 1, 0, 1. Parallel output 1, 1, 0, 1. Parallel input 1, 1, 1, 1. Parallel output 1, 1, 1, 1. Thus, we have constructed and tested the shift register using RS flip-flop IC74LS279. Construction of serial shift register using D flip-flop IC74LS379. This shift register requires IC74LS379 D flip-flops, a 16-pin dual inline package. IC74LS379 is designed to store 8 individual bits of data, and its operation is influenced by clock signals and data enable signals. Identify the code number printed on IC74LS379 using a magnifying lens. Identify pin number 1 of the IC. It may have a small notch or dot to indicate a pin number 1. Make sure that the IC is correctly aligned in the right position over the breadboard in the digital trainer kit. Gently insert both lines of pins of the IC into a breadboard, ensuring that each pin goes into a separate hole. Be careful not to bend the pins or force them into the holes. Connect the pin number 8 to ground and pin number 16 to power supply plus 5 volts VCC. Connect the serial input data at pin number 4. Connect the pins 2 to 5, 7 to 12, 10 to 13 to feed the output from flip-flop 0 to the next flip-flop 1 and from flip-flop 1 to flip-flop 2 and so on. To observe the outputs, connect the pins 2 QA, 7 QB, 10 QC and 13 QD to the LED outputs in the digital trainer kit. Switch on the power supply plus 5 volt VCC. Apply logic 1 to the serial input and apply clock pulses to the CLK pin. For each clock pulse, the shift register should shift the serial input data by 1 bit. Verify that the data with the truth table. Clock pulse 0, QA 0, QB 0, QC 0, QD 0. Clock pulse 1, QA 0, QB 0, QC 0, QD 1. Clock pulse 2, QA 0, QB 0, QC 1, QD 1. Clock pulse 3, QA 0, QB 1, QC 1, QD 1. Clock pulse 4, QA1, QB1, QC1, QD1. Clock pulse 5, QA1, QB1, QC1, QD0. Clock pulse 6, QA1, QB1, QC0, QD0. Clock pulse 7, QA1, QB0, QC0, QD0. Thus, we have constructed and tested the shift register using D flip-flop IC74LS379. Thus, we have discussed how to construct a shift register using RS flip-flop IC74LS279 and D flip-flop IC74LS379 and verify the truth table.